Hey there. Welcome back to Netbooks, Video Learning. Today, you've joined me for Algebra, Part 5. Before we begin, let us understand the learning outcomes that this video addresses. The first learning outcome is linear inequalities. We will change the equal sign in equations to a greater than, or less than sign, and then interpret, after solving for the variable. We will cover this theoretically and then do 2 exam questions, to solidify your understanding. The second learning outcome, covered in this video, is literal equations. These are equations that describe the world around us. We learn to rearrange any equation and make the variable that we need the subject of that equation. In this video, we will cover simultaneous linear equations. This topic will continue with you until the end of your school years. Please pay close attention to the examination questions covered. The fourth and final learning outcome, again, requires special attention. Word problems. Understanding what to choose as the variable, and writing out other factors in terms of that variable, is the key skill that we will expose you to in this video. Let us begin. Linear inequalities. We have this inequality. A, B, C, D, and E are numbers. And we have one variable, which is x. The aim is to get the variable on its own. With equations, we would move terms to the other side of the equal sign. The difference here is that we move terms to both the left and right hand side, each time. Let us multiply throughout by c, to get rid of the denominator. Notice that we can cancel this out. The next term to remove is b, we subtract b. And the term cancels out. We now have ax. And we want x alone. Dividing throughout by a, we are able to cancel the a in the numerator and the denominator. X is now on its own. We have successfully solved for x. The next step is to interpret the inequality signs. We know the value of the 2 points that describe x. We need to represent this on a number line. We put down the values of the 2 points. Next, we must determine if these values are included or excluded. This handy table shows us, in the first column, that excluded values are represented with open circles. And in the right column, we see that included circles are colored in. Let us look at our answer. The first point is included. And so, we must color in the circle. The next number is excluded. And so an open circle is correct. We have now covered the theory behind linear inequalities. Time to apply this to exam questions. The examiner has asked us to solve for x. This question is worth 2 marks. As we have discussed, the aim is to get the variable alone. And we need to apply the changes made throughout. Alright. So the first thing we can do here is get rid of the denominator. We multiply throughout by 2, and we can then cancel on the left-hand side. Let us write out what we are left with. We score our first mark for this question. We see that we have 2 terms on the left-hand side. And we only want x. So we must subtract 5 from both the left and right-hand side. The 5's cancel out, and we have only x remaining. This is what we wanted. Simplifying the answer, we arrive at the solution. X is greater than -9. The final mark is allocated to this answer. The second part of this question says, if x is an element of real numbers, represent the solution on a number line. No problem, we know how to do this. We draw in the number line in the value of -9. It is time to interpret the inequality. We see that this is greater than, and not equal to. Therefore it is excluded. We refer to our handy table and see that this means an open circle. X is everything greater than -9. And so the arrow starts at -9 and goes on forever. We have a mathematical term that we use with interval notation to describe what forever means. That is infinity. Using interval notation, we open an excluded bracket for the -9 and close with an excluded bracket for infinity. Why? Well, infinity is not a defined number and cannot be included because of this. We have scored the mark for this question. We have completed the first exam application question. Let us do another. Here we are asked to solve for m. The 8 must be removed to get closer to having m alone. Let us subtract by 8 throughout. When we do so, the 8's in the center cancel. Simplify and write out what is left. Notice that we need to get rid of the -3, in order to have m alone. We achieve this by dividing all the terms by -3. When dividing an equality by a negative number, something special always happens. Let us consider 2 less than 3. If we divide these numbers by -1, we get -2 and -3. Is the inequality sign still true? -2 is not smaller than -3. Therefore, to make this statement true, we swap the inequality sign when dividing, or multiplying by a negative number. We need to divide throughout by -3. We swap the inequality signs around and are able to cancel out the -3 in the numerator, and in the denominator. This manipulation awards us our first mark. We have now solved for m, and can write out the final form. The second mark is allocated for the correct final answer. The second part of this question asks us to write down the number of integers that satisfy the inequality. We note the integers between -1 and 4. Noting that -1 is included. We can count the integers. 1, 2, 3, 4, 5 integers satisfy the inequality. We have attained our mark and completed the question. The first learning outcome has been addressed. Next we will dive into the reality of literal equations. Literal equations express variables in terms of other variables. Let us consider a few examples. V equals d over t. The equation for speed. This is distance over time. Another example is the area formula for a circle. Given by pi, r squared. R is the radius. A last well-known literal equation is the area of a rectangle. Length equals breadth times height. You will need to know how to make the variable that you want to calculate the subject. Let us do an exam question. Solve for the variable n. When given the equation, PV is equal to nRT. This is the ideal gas law. Do we need to understand what each variable means in order to express this in terms of n? Absolutely not. We can rearrange any equation and make the variable that we want to calculate the subject. Do not be intimidated by the variables. We notice that n is on the right-hand side, along with RT. We divide throughout by RT, allowing us to cancel the numerator and denominator, freeing the n. This scores us our first mark for the exam question. We can write out this equation in terms of n as n equals PV over RT. The final mark has been allocated to the correct final expression. We have completed learning outcome 2. And can now rearrange equations in terms of any variable that we want. The third learning outcome covers simultaneous linear equations. Let us dive in. Simultaneous, linear equations are equations that have the same two variables in them. The best way to describe the method of simultaneous equation solving is to do an exam question. Let us use this as an opportunity. The examiner has requested that you solve for x and y simultaneously. We are given two equations, both in terms of x and y. Applying the substitution method, we must get an equation in terms of one of the variables. Let us take the second equation. To get y alone, we bring it to the left-hand side and move the 2x over to the right. We now have a third equation in terms of y, and have been awarded a mark. This is called the substitution method because we take this equation in terms of y and substitute it into equation 1. Replace every y with the equation 3, and by doing so we have earned a mark. Lovely, it is time to simplify by multiplying the 4 into the bracket. Grouping terms, we have -3x equals 9. We solve for x to be -3. A mark is allocated to this answer. One variable solved. Now, what about y? Well, we have an expression for y and we can substitute our now known value for x into this. We calculate y to have a value of 9. The final mark is achieved for this question. Let us redo this problem but using the elimination method. When we eliminate, the aim is to make the coefficients of one variable the same, so that when you subtract, that variable is cancelled out. Let us note equation 1 and equation 2. Moving all variables to the left-hand side, and asking ourselves, what can we multiply or divide by, to make the variables the same? Let us go with making the y's the same, as there is a y with no coefficient in equation 2. That makes it easier. If we get the y in the second equation to be 4, it will then cancel out when subtracting the two equations. We multiply equation 2 by 4. Simplifying, we obtain a new equation, and score ourselves the first mark for the question. Time to apply elimination, we write out equation 1. And begin to subtract equation 4 from equation 1. This gives us 5x minus 8x. Which is negative 3x. 4y minus 4y is 0. Objective achieved. And lastly, 21 minus 12 is 9. The result is negative 3x equals 9. This earns us a mark. Solving for x, we discover that x is equal to negative 3. A mark is allocated to the correct answer. This is the same as we previously calculated using the substitution method. Next, let us substitute this x value into any of the equations and solve for y. Substituting x into the expression for y, we can easily solve y to be 9. The final mark has been awarded. We have achieved the same answer using substitution or elimination. We have addressed learning outcome 3. The final learning outcome will cover word problems. Word problems involve reading and interpreting a scenario. Let us consider the scenario posed by the examiner. Steve is currently 4 times as old as his daughter named Linda. 6 years from now, Steve will be 3 times as old as Linda. What is Linda's current age? With word problems, we need to set something to be a variable. And then describe all the other factors in the question, in terms of that variable. How do we decide the variable? It is usually what is asked of you in the question, but it can also be what has the most value. This question asks us to solve for Linda's age and gives us information relating to her age. Let Linda's age currently be x. The question says that Steve currently is 4 times older than his daughter. Therefore Steve's age is 4 times Linda's age. That gives us 4 times x. We have scored our first mark. The question then goes on to mention 6 years from now. Well, 6 years from now, Linda and Steve will be 6 years older than they are currently. So we can add 6 to their current ages. And we now have how old they are 6 years from now. A mark has been awarded for this step. Let us read further. 6 years from now, Steve will be 3 times as old as Linda. So, being 3 times as old. 6 years from now, Steve's age is 3 times Linda's age. Well, we have now used up all the information from the question. We have already calculated Steve and Linda's age 6 years from now. So we can happily substitute that into the relationship for 6 years from now. The examiner gives us yet another mark. Alright. Let us multiply the 3 out into the bracket and simplify further. We calculate x to be equal to 12. What was x again? Recall that x was set to be Linda's age currently. That is what the question asked us to solve. Linda is 12 years old. We have successfully solved this word problem, scoring our final mark. The fourth and final learning outcome has been addressed, and these key concepts are in your arsenal. Voila, we're done with today's video. Thanks for joining me. Catch you again next time, on Netbooks, Video Learning.